Hey everyone, and welcome. Today, we are diving into a question that honestly feels like it's been pulled right from a science fiction movie, but it's one that physicists and philosophers are taking very, very seriously. What if the fundamental rules of our reality, well, what if they aren't so fundamental after all? So this whole thing kicked off with a brilliant question someone asked on Reddit. And it's a real head-scratcher. Since we're physical beings made of the very stuff governed by these laws, would we even have a clue if they were slowly changing? I mean, would our rulers shrink along with the space they're measuring? Would our clocks slow down along with time itself? It's this deep, fascinating rabbit hole.
The amazing Douglas Adams just nailed this feeling of cosmic uncertainty. He frames this not just as some dry physics problem, but as this huge philosophical question about reality itself. And that little twist at the end, this has already happened. It's unsettling, right? So, to even begin to find out, we have to get really clear on what we mean by a law in the first place.
All right, so before we can even ask if the laws are changing, we've got to get one really important idea straight. It's a classic distinction, famously known as the difference between the map and the territory. Okay, think of it like this. All of our scientific theories, Newton's laws, Einstein's relativity, that's the map. It's our best attempt to describe how reality works. And that map, oh yeah, it definitely changes. We are constantly updating it, erasing old routes and drawing in new ones. But the original question is asking something much, much deeper. It's asking if the territory itself, the actual underlying fabric of the universe, could be shifting under our feet. And asking that question, well, it plunges us headfirst into a philosophical debate that has been raging for centuries. People have argued forever about whether the laws of nature are just some kind of cosmic accident or if they were somehow completely unavoidable. So you've basically got two main camps here. On one side, there's contingentism. This is kind of the traditional view. It says the laws just are what they are. The universe was dealt a certain hand, and that's that. Gravity could have been stronger. Light could have been slower. On the other side, you have necessitarianism, and this view argues, nope, the laws could not have been any other way. They are a fundamental, necessary part of what reality is. Now, a really popular version of this is something called dispositional essentialism. And the idea here is super interesting. It says that a law, like the one for electric charge, isn't just a rule that charge happens to follow. No, the law comes from the very essence of what charge is. To be a positive charge means you have the power to repel other positive charges. The property and the law are basically the same thing. Okay, but this is the big hang-up, right? It feels so simple to just imagine a universe with different rules. If I can picture a world where electric charge follows an inverse cube law instead of the inverse square law we have, doesn't that prove the law isn't necessary? Well, the necessitarians, they have a really clever answer to that. So here's their comeback. They'd say, sure, you can imagine a property that follows an inverse cube law, no problem. But whatever that thing is, it's not charge. It's something totally new. Let's just call it schmarge. And schmarge follows its own law. Let's call it Shmulum's law. So by this logic, you haven't actually imagined changing the law for charge at all. You've just imagined a different universe with a totally different property. The law for our charge remains exactly as it must be. Pretty clever, right? So, while the philosophers are over here having a great time debating the existence of schmarge, physicists decided to take a much more direct approach. They basically said, you know what? Let's just go out and look. Let's see if we can catch the laws in the act of changing. But how on earth do you even test the stability of reality itself? The key is to measure what are called the fundamental constants of nature. These are the special numbers, like the speed of light or the strength of gravity, that are baked right into the equations of physics. The thinking is, if the laws themselves were shifting, then these fundamental numbers should be shifting too. Scientists are focusing their search on a few really critical constants. You've got the fine structure constant, alpha, which basically controls the strength of electromagnetism. The force that holds atoms together. Kind of important. They're also looking at things like the mass ratio between protons and electrons. These aren't just random numbers. They're the pillars of our reality. If any of them are drifting, that's our smoking gun. And the way they're hunting for these changes is just brilliant. It's a two-pronged attack. First, there's the here and now approach, using ridiculously precise atomic clocks to look for any tiny drift happening right now in labs here on Earth. Second is the there and then approach. This uses giant telescopes to look at light from quasars that has been traveling for billions of years. That ancient light is like a time capsule, telling us what the constants were like way back in the early universe. And this right here, this is what that search actually looks like on paper. It's a plot showing measurements of that fine structure constant. Basically, if the laws are perfectly 100% stable, all the measurements should land on that zero line in the middle. The ovals just show our margin for error. So the key takeaway is super simple. As long as the 0 point is inside the oval, it means that, as far as we can tell, nothing has changed. So after all this philosophical wrangling and incredible, mind-bending science, what's the verdict? Have we actually caught the universe red-handed trying to change its own rules? This is the moment of truth. After all these years of measurements, from our own planet to the most distant objects we can see, what's the answer? Are the foundations of our reality solid, or are they shifting sand? The answer, so far, is a resounding no. Based on all the data we have, the scientific consensus is clear. There is no statistically significant evidence that any of these fundamental constants are changing. As far as we can possibly tell, the laws of physics are rock solid. And just look at how solid. This number here represents how much the fine structure constant could possibly be changing. We're talking parts per billion. To put that into perspective, that's like measuring the distance from New York to Los Angeles and being sure it hasn't changed by more than the width of a single human hair. The universe is just astonishingly constant. Now, you might be thinking, great, science for the win, mystery solved. But it's not quite that simple. We actually need to go back to where we started, back to that whole idea about the map and the territory. So let's be really clear about what science has told us. It's given us an incredibly powerful, data-driven answer. Our map of the universe is now way more detailed. And a huge part of that map is the fact that the territory, the underlying reality itself, seems to be unbelievably stable. So is that it? Case closed? Does this amazing scientific result mean that the necessitarians were right all along? Does it prove that the laws couldn't be any other way? Well, not quite. See, finding no evidence that something is changing is not the same thing as proving it can't change. Our map is better than it's ever been, but it is still just a map. We've confirmed that the territory is stable, but we still don't know why it's stable. Is it because the laws are necessary, or did we just get lucky and happen to live in a universe with contingent but very, very constant laws? That deep mystery is still there. And this brings us right back around to the very heart of that original question. The data says the laws are constant, but what if the change is something that we, as creatures literally made from those laws, are fundamentally incapable of ever perceiving? It's a humbling thought, isn't it? That even with all our incredible science, the ultimate nature of reality might still be hiding from us, right in plain sight. Thanks for listening.